All right, now we're getting into the word problems dealing with exponents. And a colony of insects has an initial population of 600, and the number of insects triples every 4 weeks. So this is actually kind of a tricky problem for writing your function. So the initial number of insects, so n of t, is 600. And then it triples, so the rate is tripling. So r is 3. Ignore that strange vertical line that sometimes shows up. And then a lot of people want to just put a t here, but it's tripling every 4 weeks, so it's really t divided by 4. So this is really the number right here, t over 4 is the number of 4-week periods they're going to have here. So letter B, what will the number of insects be after 7 weeks? So 7 weeks, remember, is like 1 and 3/4 time periods, and that's why, again, we had to divide by 4 there. So this is 600 times 3 to the power of 7 over 4. Now, order of operations tells you need to do 3 to the 7/4 power first in the calculator, and then multiply that answer by 600. So that's 4103.4 something, and this said to the nearest whole number, so it's 4103 insects. So 4,103 insects. Let's see. How many weeks will the number of insects be? 12,000. So that's n of t. So n of t is 12,000 equals 600 times 3 to the t over 4 power. So we want the exponent by itself, so we're going to divide by 600. And we get 20 equaling 3 to the power of t over 4. Again, we're in exponential form, and 3 and 20 don't share a base, so we have to make it a log. Log base 3 of 20 equaling t over 4. This we can simplify because we using change of base log of 20 over log of 3. You're going to get that answer, and then you're going to take that answer and set it equal to t over 4. Then multiply through by 4. So the exact answer is 4 times log of 20 divided by log of 3 is going to be equal to time. So for letter C, time is 10.907. And make sure you're labeling that they're talking about weeks here. Don't leave answers without labels in word problems. All right. A house has a value of $530,000 and it's decreasing. So this is exponential decay formula. So the initial value, V of t, and you have to use their variables unless you choose to redefine them. So the initial is 530,000. It's decaying or decreasing, so it's 1 minus 0.08, 1 minus the rate to the power of t. So that is the model. And a lot of students, and I as well, like to simplify that. That's 530,000 times 0.92 to the t power. So for letter B, the value of the house at the beginning of 2013. Well, we need to figure out, you don't want to put 2013 in here because this formula is since 2008. So 2013 minus 2008 is really only 5 years since the house started to lose value, not 2013 years since then. So that value was 530,000 in 2008. So it's been 5 years since then. So we're finding V of 5. So you're plugging 5 in for t. So it's 530,000 times 0.92 to the power 5. And again, do the exponent first. So 0.92 to the 5th power. And then take that answer and multiply it by 530,000. And the value is 349,313. And that's to the nearest dollar. 26. Population is growing continuously. So continuous growth is that PERT formula. So A of t is going to be equal to the principal or the initial amount. I think it's this also can, I use the PERT formula every time I hear compounded continuously. but also they use different letters and different formulas. On the formula sheet, let's see what they give you for this. They just show you the PERT formula, so we just have to adapt it. So the initial population is 1,000. We want to find the continuous growth rate. So we know after, we're solving for R, and after 8 years, I apologize. Let's see here. Let's start this again. Okay, so it is growing continuously. It has an initial value of 400. The 400 goes here. To the times E, we're solving for R. We know T is 8. And we want to know when the population is going to be a final population of 1,000. You know how to solve this. This is an exponential problem, so we want to get the exponent by itself. Divide by 400 then. And we're going to have 2.5 equaling e to the 8r power. E to the 8r power. That is a big E. Okay, so to solve this, you take the natural log of both sides, or log base E, which is ln of 2.5, takes ln of both sides, equaling 8r. Divide by 8, and the exact answer is ln of 5. 2.5 divided by 8 equaling r, so our rate is going to be 0.115, which is a rate of 11.5% per year. 27. Jack's putting $5,000 into the bank and he's earning 6% compounded monthly. Okay, so compound interest formula is again also given to you on the front. So it's A of t equals P times 1 plus R over N to the power of N times T. So the initial amount he puts in the bank is your 5,000. That's your P, principal. 1 plus the rate is 0.06. Compounded monthly, how many months in a year? That means N is going to be equal to 12, because there's 12 months in a year. The power of 12 times T, and we want to know how long it takes to become $6,000. The final amount would be 6,000. Okay, so there's a whole lot to do here. What I did next is I simplified what was in here. I took 0.06 divided by 12, and then I added 1, and that got me 1.005 to the 12t power. I divided by 5,000, and I got 1.2. So now I'm in exponential form. Can't do anything more, so I'm going to make it log. So log base of 1.005 of 1.2 equaling 12t. And to get the answer, you just divide by 12. So that is the exact answer right there. But to actually get the answer in the calculator, again, the slightly older calculators is change of base formula. So log of 1.2 divided by log of 1.005. And then take that answer and divide it by 12. And when you do that, t is equal to 3.046. Not so easy. You got to stop here and pay attention, because it wants to know how many years and months. And this is definitely 3 years. That's the easy part. But we need to know 0.046 is in terms of like it's over 1,000, but in terms of tenths. But we want to know it in terms of twelfths. So this is going to, if you solve this equation 10x equals and you multiply those, you're going to get 0.0052 months. Sorry, 0.552 months, which is a little, it rounds up to 1 month. So it's 13 years and 1 month. I would expect to see this question where they're asking you to convert from your decimal to months and years. Finally, they're giving you a formula. They're saying the population at the beginning of 2010 is given by this formula. So this is the initial population, which is 1,300. Rate of growth is the 0.04, which is 4% per year. Again, that's your R here. That's P-E-R-T. Principal, or initial amount, e to the r times t power. What's the population at the beginning of 2020? 2020 is 2010 is 10 years. So for letter C here, we're going to plug in 10 years. We're going to find P of 10. So 1300 times e to the 0.04 times 10. So that's 1300 e to the 0.4 power, which is 1939.372. But they asked you population, you can't have part of a person. Whoops. So therefore, we don't have a full person yet, so we leave it at 1939. Letter D, when is the population going to be 2,500? So 2,500 just goes on the left. We want to find the time period it takes for that to happen. So we are solving this. We have to divide first by 1,300. So I believe we now have 2,500 over 1,300. I'm just going to leave it like that because it doesn't go in exactly. Equaling e to the 0.04 t. So you can drop and crisscross, or you can just take the natural log of both sides. So this is going to be ln of whatever 2,500 divided by 1,300 is, equaling 0.04 t. And then you're going to take that answer, divide by 0.04. So again, this is the calculator problem, so just go ahead and plug that in. So divide that, take the natural log of it, divide by 0.04, and it's 16.348 years.